Broadcast is now starting. All attendees are in listen-only mode.
Hey, what's going on, everybody? Jason Allen here, excited to be with you for our Friday pajama presentation, Mountain States Concrete Pipe Association webinar. Let's go ahead and get started. I want to recognize a few guests with us here today. I want to recognize Randy Wahlen from Oldcastle Infrastructure. How are you, Randy?
I'm happy it's Friday.
Happy it's Friday. Wonderful. We also have Heather Christensen with Geneva Pipe and Precast. How are you, Heather?
I'm doing well, Jason. Thanks for having me.
Absolutely. And also with us, we have Mr. Mike Blackham from Geneva Pipe and Precast.
Hello, Jason. Doing well. How about you?
Doing very well. Thank you very much. So we've got a great presentation prepared for you today to talk about sizing precast concrete drainage structures. Just a couple of housekeeping items as we go through here. I've got a handful of poll questions that I want to go over with you. I do have a handout that I've uploaded that I would at some point like all of you to download. We will be going through that towards the end of the presentation, so feel free to go through and download that. But I just wanted to let you know that is there, that is available. We will be going through that, and that's going to be really helpful for you after this to kind of go back as a reference. So let's go ahead and get started. For those that don't know me and haven't been attending these webinars, Jason Allen's my name. Wearing funny pajamas is my game. University of Utah grad with bachelor's and master's degrees in water resource engineering. Been in the civil engineering field for 18 years. Started out as a surveyor, went into land development, worked in the public sector as the Morgan County engineer and public works director. Got back into consulting. I've started my own business, and I now do marketing engineering for the Mountain States Concrete Pipe Association. Mountain States Concrete Pipe Association is made up of two main member companies, Geneva Pipe and Precast, with offices and plants in Salt Lake, Orem, and St. George, and also Oldcastle Infrastructure with plants in Ogden, Idaho Falls, and the Boise area. We also want to give recognition to Ashgrove and Wholesome, who sit on our board of directors for Mountain States Concrete Pipe Association and are our cement suppliers. Just a quick recap. These are the pajama presentations. Our purposes are to build some technical skill for you, to provide a break during your day, and for those of you that are working from home, and also allow me to be the center of attention. Here is my pajamas today. This is courtesy of Heather Christensen, and her deciding this is what I should wear. Here you have it. There it is, my flying squirrel jammies, Heather. What is it? Is it everything you hoped it would be? I got it.
It's everything, you know, from the picture on Amazon or wherever you purchased, they looked a little bit higher quality.
It's actually pretty high quality, to be honest with you. It's pretty comfy.
Oh man.
Can we get a picture of you jumping off the garage?
Yeah, absolutely. I will video that later of me jumping off the garage in my flying squirrel suit. That is not a bad idea. Not a bad idea at all.
I didn't really think these would go for so long or have any popularity at all. But I saved my pajama picture for a later one.
Oh, you saved your pajama. Oh, great.
Let's see.
Is it PG?
Yeah, can you see it?
I'm not even looking at webcams, right? I'm not looking at your webcam.
You bunny rabbit.
It's a mountain goat.
You're a bunny rabbit.
and we purchased that for Steve Oldham's retirement because someone had accused him of being the goat man that used to dress up as a goat and go up on Willard Peak. And so that's how to shout out to Steve. We got him the pajamas, and they may not have been clean when we got them to him.
Well, anyway, if you want, Randy, feel free to send that to me. I'll go ahead and put it in. Go ahead and put it in my presentation for next week. So, as I mentioned, we've got some housekeeping things. We're going to do a couple of polls right now. This is our 8th webinar that we've done. We've done them every Friday, beginning early or in late March, and we've been loving doing these. We've been having great response, great attendance. So I wanted to launch a couple of poll questions, and keep in mind for those of you that are watching this webinar, if it's in full screen mode, some computers won't allow you to vote in the poll. So get out of full screen mode to vote, and then you can go back in. But we're going to do a few poll questions right now, and then we'll see where that goes. Hang on here. Let me open up my poll questions. This one is, I'm curious to know, how many of these webinars, for those of you that are on the call, how many of these webinars have you attended?
Jason, I hope you have a poll question at some point to see if people would be interested in ongoing webinars even after this whole COVID-19 thing blows over, whether it may be a monthly or a quarterly webinar hosted by Mountain States.
Well, I'll tell you what, if that's what your hope is, you're going to be sorely, sorely excited in a moment. All right, it looks like we've got most of you there. I'm going to close and share that. So it looks like about 30% of you, this is your first one. But for the most part, it looks like the bulk of it are between 2 and 7. So a lot of you are attending multiple webinars. That's good. That's good. That makes me happy that you've decided to come back a time or two.
For the people who've attended all 8, I am very impressed and proud of you guys. I haven't even been on all 8, so keep it up.
As am I. I'm very, that's exciting. That's cool. 11% of you. That's great. That's great. Okay.
I'm kind of worried about that. It must be strictly for continuing education.
It must be. So with that in mind,
That's what I was going to say, Randy.
Here we go. On a scale of 1 to 10, how beneficial have these webinars been for you? 1 to 2, not beneficial at all. 3 to 4, not as beneficial as I'd hoped. You could be honest. 5 to 6, average beneficialness. 7 to 8, very beneficial. Now, these are the technical ones, right? So I want to know what the technical, how good the technical, and then I'm going to ask you about non-technical, because we did a few non-technical as well. So.
And Jason, why don't you point out too, or I guess I'm pointing it out right now, is the answers to this are anonymous, right?
Yeah.
So even if someone decided that really they haven't gotten a lot of benefit out of them, we wouldn't know. It's just the polls. We get the percentage, right?
Yep. Correct. Correct. All righty. Okay. I'm going to go ahead and close that one and share it. It looks like a good percentage of you say it's above average or above average beneficialness. So that's good. 5 and above. Thank you very much. That's good to know. And then I'll ask one more here, and we'll look at the non-technical presentations. We've done a handful of those about effective presentations and the one on millennials, and but I think 5 of them have been technical and 3 have been the non-technical. So how beneficial have the non-technical presentations been?
And for those of you that don't want to be anonymous and want to complain about Jason, just text me. I'd be happy to get your responses.
Okay, perfect. Wonderful, wonderful. I'll give it just a couple more seconds here. Okay, I'm going to close that out. Wonderful. All right, and share it. Here we go. All right, so you can see about pretty similar, but a little bit more on the high end of very to extremely beneficial. A few more that did. That's great. Excellent. Thank you very much for that. I appreciate it. I've got a couple more throughout. Maybe we'll go through. We'll use those polls. We'll break them up a little bit more. I've got a few more questions that I want to ask you. So, but we don't want to do that the whole time. Let's jump right into it. So the takeaways today. I'm going to briefly talk about some of the changes that we're working with UDOT on catch basin drawings, and when we also have some. We've been coordinating with the APWA spec committee, and so some of these changes will also be implemented in the APWA specifications as well once we're done with this UDOT. We're hoping this summer or early fall, depending on when the meeting schedule is for UDOT, for the standards committee, and when we can get these approved. But we're looking at an adoption definitely before the UDOT conference this year is our hope. As far as we're also going to talk about sizing catch basins and what you should keep in mind when you're sizing those catch basins and sizing manholes. So let's jump right into the UDOT precast catch basins and what we've got there. Now, as we met with UDOT and we talked with them, we estimated that between 90 and 95% of all the boxes in the UDOT that were done in UDOT are actually precast. However, with that, we have to do a design because most of the standard drawings are cast in place. So we have to do a special design and submittals, and then there's a review and QC process, and it's really cumbersome, and it's a lot of work for UDOT and for us to do that. And so our goals in this is we wanted to standardize manufacturing and have just one standard drawing that would show a majority of sizes and depths so we could capture as many as we could, and then also standardize the design process, as well as eliminate these large submittal packages that the REs and the structures group were reviewing at UDOT. And so that was our main goal as we first started meeting with UDOT a few years ago on this. This is a couple of examples. This is the CB5. This is a cast-in-place catch basin, and it has this one. You can see it goes from 4 feet to 8 feet in length, perpendicular to the grate and the direction, or the perpendicular to the flow of your storm drain there. It's a standard 5-foot width. There, that's your outside diameter, so that would be, or excuse me, your outside width, so that would be 4 foot internal typically, and that goes from 4 feet to 12 feet deep. The CB9 is kind of similar, also a cast-in-place drawing. This 4 feet to 8 feet, perpendicular to the flow of that where that pipe is showing, and then it's typically about 5 feet. But this one goes from 3 foot 10 inches to 30 feet 9 inches deep. CB10 is similar, but it's the opposite direction where it can go wider. So if you need your pipe coming into your box on the other side, this is where the CB10 is. Now, as you go through it, this is what it looks like now. This is the CB9 sheet. This is what we've got. So this is your cast in place. Up here on column A, I'll just kind of zoom in so that you can see what all of these things are. So you've got all your dimensions and your number of manhole steps that you have to have in there. It gives you your reinforcing steel, the length of everything. It's very, very large. You know, you go through and just calculate the weight of your steel, you know, for your bid. And I mean, it's a really, really, really big, cumbersome process to go through and work on these. Now, a few years ago, and Randy was involved in this. This was before I got there. I want to say it was about 10 years ago. Am I correct, Randy? Or was it a little bit longer? When was 2012?
Probably about 10 years.
Okay, so about 10 years ago, the Mountain States Concrete Pipe Association and our manufacturers went to UDOT and said, you know what, we need to have some option for precast because we're just doing so many precast things, and let's look at adopting a precast drawing. And so they put in this precast spec. This is, or standard drawing. This is CB12. Couple of things about this though. This is why we're trying to update these now. Is there are some restrictions here. Number one, it's non-reinforced, so we're restricted on how big we can go and how deep we can go. Okay, that means there's really no structural steel in any of these boxes, only handling steel. So we'll put a little bit of steel in it. You could see that on section AA and section BB. There's a little bit of steel, but that's just in the corners for handling steel so that the box doesn't get damaged while we're transporting it and moving it around. Okay, this is, as you look over here, this is the sizes of the boxes that you can go. I'll zoom in on that in a moment here and show you a couple of other things. The depth to the bottom of the base, the maximum depth from the top of your grate to the bottom of the base, not the flow line, but the bottom of your base is 8 feet. So that's the deepest that we can go on these. And then we need to provide core holes that are a minimum of pipe diameter plus 4 inches. So that's another. So that would basically be 2 inches on either side. So if you have a pipe diameter of 18 inches, you then go your outside diameter of an 18-inch pipe is 2.5 inches thickness. So that'd be 5 inches. So your 18 inches becomes 23 inches. Add 4 inches is 27 inches. So keep that in mind. And then you need to cut the core holes at the plant. And the center of the core holes to leave 2 inches of concrete measured from the inside wall of the box to the core hole. and locate the core hole vertically to leave a minimum of 5 inches of concrete directly above the core hole to the top of the box. So that's something that you need to keep in mind, and we will be talking about that later. Do not use this drawing when water table is within 5 feet of finished grade. So if your water table is above 5 feet, if it's 4.5 feet, you're not allowed to use it. Now the interesting thing is, what if your box is only 4 feet deep and the water table is at 4.5? Unfortunately, you still wouldn't be able to use this even though the box is above the water table. It's kind of interesting. All right, I said I would zoom in on that box. These are the sizes that you're restricted to right now on CB12. You can go a 1.5 by 4 foot box all the way up to a 4 by 4. And remember, only 8 feet deep to the bottom of the box. So that's, there's quite a few applications you can use this on, but unfortunately, if you get deeper than 8 feet, or if you have a pipe that's a little bit larger that we'll be going over today to show you what your restrictions are, then you're going to have to use one of those cast-in-place drawings for now until we get these other ones done. So we've been doing these structural calculations according to ACI 318 and ASTM C890, and also designed per AASHTO LRFD. Our goal is to put together one standard drawing that would replace CB5, CB9, CB10, and CB12. So we would be able to consolidate from 4 standard drawings down to just the one. Now, the other standard drawings would all be archived and could still be used if you had a situation where you needed to use cast in place. But for the most part, we're hoping that most people will realize that if we're already doing precast, we can just call them out on this. And it's going to really simplify the inspection, the RE reviews, the structural reviews, and our submittal process as well. And then we would have a process for special design. So if there's any sizes or any depths, or if there's unusual circumstances, we would have a process for how you can go through and design those. And that would mostly be for the manufacturer. So the design engineers shouldn't have to worry about that too much. But that's just for us as manufacturers on what the process we need to follow if there's a special design. Okay. So this is what the drawing looks like currently. This is kind of in a draft form still until we get this finalized in the next couple of months and get it approved. But this is what it would look like. It's similar to the CB12. It's kind of based on that, but it would give you all the dimensions and everything of the steel and how that works. This is the second sheet that we've put together. What's cool about this is we have this. This was requested by our good friend Jeff Erdman when he, this just is a great table that would show all the design engineers what the acceptable grates and frames are based on box size. So you could look at this table, and if you say, oh, I need to use I have a 4x4 and I need to use a GF15, and you go over and go, oh, yep, I can use a GF15. That is acceptable in that 4x4. Or if you say, well, I got a 2x3 box, can I use a GF16 in a 2x3? And you go over, oh, I can't. Okay, so it's just a good check there. The other thing that that Jeff asked us to put in there that I'm really excited that he did is this skew angle. A lot of times, and we'll talk about skew angles today, but a lot of times when we come in at a skew angle, it affects the size of box we can use. So what this is the minimum L1 or L2, which if I go back to table 1, that just gives your length, right? That's the length of your, or the size of your box, right? And that would be the dimension of your box there. And that would be your inside dimension, okay? So your minimum skew angle here, or your minimum lengths based on skew angle. So if you had a 30-inch pipe, for instance, and you came in at a 25-degree skew angle, or we'll keep it easy. You go to a 20-degree skew angle, it would be 4 feet width. So you would have to have a minimum 4x4 box. And if you needed a 27-degree skew, then you would go up to the 30%, and then that would be 30 degrees, and that would be a 5x5. So now you would need to increase the size of your box. But this is a good check for designers so that they can check their skew angle to make sure that their pipes can fit. Now we're going to go through, and I'm going to give you in that handout, hopefully you all had a chance to download it, but in that handout, you'll be able to you'll be able to go through and calculate this if your skew angle is different, or if you have multiple pipes coming in and different things, and just a good check. So I've got all of that included in that handout, and we'll be walking through that today. This is the design data table that we included, just shows all of our loads and things. These are, I'm not going to go through all of this, but this is what you can take a look at once these standard drawings come out. This will be included in it. Also our QC tolerances. So this is what the table looks like currently for those cast in place drawings. Like I said, this is the CB9. So this is the steel table and how you figure out how much steel you need, how long it is. It is every bit as intense as it looks if you've never used it. And this is what the new table will look like, something like this. This is just gives you the dimensions. I'm going to zoom in on this area here, and then I'm going to zoom in on this next. So the first area, if I look at this, I've got my 4x6 box on the left, and then I've got incremental depths going up all the way up to an 8x8, and it says up to 6 feet. Each of those require a single cage. Up to 12 feet, they all still require a single cage, and you've got your horizontal and vertical steel areas, and that's in square inches. What your steel area needs. If you notice, once you get past 12 feet deep, you need to change to a double cage. So it would be a double cage situation where you've got your outside steel and your inside steel, and then you've got your horizontal and vertical steel areas. So it's a little bit easier to read than the other one. This is a table. This is just a reference table here. So maybe a manufacturer has a bunch of number 4 bars laying around, and they need to come up with maybe the steel area required was 0.29, right? So they would say, all right, it's 0.29. So if I'm using number 5s, I could do number 5s at 12 inches. Or if I'm doing number 4s, I could do number 4s at 8 inches. So it all depends on what the availability is, how quick the manufacturer can get those in, what they have on stock. So it really allows some flexibility instead of just saying in the design, you have to do number 5s at this, number 4s at this, and that's typically how it's been in the past. But this gives them the flexibility where now you can be a little bit more flexible. You can save some money and some time and some and it's going to make it really nice for the manufacturers to be able to adjust on the fly like that. So for example, a 4x4 box 10 feet deep. This is just a quick example we'll do. So we go over to the table, we look in this area here, we zoom in, we go to our 4x4, we go to 10 feet deep. You notice up to 9 feet, no reinforcements required. You go down to 10 feet, it would be in that group between 9 and 15. You require a single cage of horizontal steel is 0.15, vertical steel 0.13. So we go over to this table, and you could do, if you had number 3s, you could do number 3s at 8 inches for your horizontal and number 3s at 10 inches for your vertical. Or you could do number 4s at 12 on both of them, or number 5s at 12. So that's a pretty minimal steel example there. Let's look at another one, 6x6, 11 feet deep. All right, so again, we go to our table, we go over to this side of the table, we would pull that up, a 6x6. Here, we zoom in. Hold on here. Sorry, I forgot. 11 feet deep. Sorry, I got distracted. 11 feet deep, so we go over to here. We look in that group between the 9 and 12 feet. It's a single cage. Horizontal steel is 0.29. Vertical steel is 0.13. So it's in that little box there. So we would go 0.29. You'd come over to this table and say, okay, I've got number 5s. I want to use number 5s. We're going to go number 5 at 12 for our horizontal steel. And for our vertical, it's a minimum steel, so it's 0.13. So we'll go ahead and just use number 3s at 10 inches there for our vertical. So that'll make that easy there. So it really gives some good flexibility to our manufacturers, and we're really excited about that. This is what the base looks like, where it just provides the details for the base. And like I say, I'm going through this pretty quickly because I want to get to actually sizing and designing some of these things for you. And this is just a good introduction to what you can expect this fall when these come out, and then obviously the lid stuff. So what your submittals typically are now, you would have your stack sheets, which would give your layout, your depth, your riser sections, your joints, and your hole locations. And so this is what we're submitting now. This is what we would continue to submit. However, right now, with every individual box we do, we have to submit a design. So we would have to go through and do calculations and design and show that what we're proposing for precast works. When these specs come in, or these standard drawings are approved, we'll be able to get rid of that design component of it, but we would still have these submittals of these stack sheets. So I'm going to go through and show you some of these stack sheets here. This is what a typical stack sheet looks like. Notice, I want to point out a couple of things. If you notice down at the like the lower right hand corner there, you see where it says right, back 48, left 48, in front. This shows the hole locations. If you in that table, you can see there's 18-inch concrete pipe coming in invert 1, a 12-inch concrete pipe in invert 2, 18-inch concrete pipe in invert 3. So notice that because of how this box is sized and depending on how we manufacture it, 1 and 3 are really good. We can make that work. Unfortunately, notice that number 2 is right in the middle of that line there. So what we've been requested on this pipe here and what they want to do is, if I don't know if you could tell, but it says over on the left-hand side, 48 inch by 48 inch, 15 inch adjustment. And so that means the contractor is planning on pouring the lid in place out in the field. And so we're not able to have our riser go up. So unfortunately, there's a core hole there that's going to be right in the top of the box. And this is what we try to avoid as much as possible. But unfortunately, there's times where it's just unavoidable. And so what you'll see, here I zoom in on that for you there. So you can see that number 2, 38.28 inches, right? It tells you what it is there. This is what that looks like when you core that out and where it goes into a hole like that up at the top. And so, we try to avoid that as much as possible. Here's another example. This one is, there's 2 core holes there because either the pipe's coming in at a skew angle or maybe it's an elliptical pipe. And so it's really interesting there where you've got that situation where it's the top of it there doesn't quite fit in the riser. This is a situation that we have to address case by case and look at there. So
Hey, Jason,
yeah, Randy.
as much as we'd like to avoid that, it's more than I mean, there's a lot of shallow drainage where we just have to deal with that. But where they're pouring that lid out in the field, it is really easy for them to tie that back together, and it works out fine.
Yeah, we had an example. Someone showed us one time, and this is where it's great, where they do that cast in place lid where they pour it out in the field, and they're able to reinforce around it and put that in there. So it is good. We had a situation one time where I think it was Jeff that showed us a picture where the pipe was put in and then the contractor used a precast lid and it sat on top of the pipe, and it was about 2 inches above where the bottom or the top of that riser. So the lid actually stood up off of the riser 2 inches there. And so they would either have to core or grind that down so it would sit flush on the pipe, or pull that lid off and just cast it in the field. So those are things that we really need to be looking at when we're designing that minimum size of pipe or that minimum cover of pipe there. So we're gonna let's do. I mean, that was kind of a lot of heady technical stuff there. Let's look at. I'm gonna do another poll real quick here. So let's do. Let's break this up a little bit. Take a little break here and launch a poll. This is for Heather here. Should Mountain States continue hosting webinars starting in June? My plan is to continue through the month of May and then reassess and look. I'm just wondering how often, if you think we should. No, we're good, thanks, though, is the first one. Yes, once a month would be nice. Yes, twice a month would be twice as nice. Or yes, keep them coming weekly. I had a 5th response that I deleted that was an option where I would just call you every day and read you a bedtime story to help you get to sleep. But I decided nobody was going to take me up on that. Or maybe too many would take me up on that. That would be a really long night. Anyways, okay, it looks like everybody's voted. I'm going to share that. So it looks like 59% want to see this keep coming once a month, and 41% would like twice a month. So that's really good to know. We were talking about this as a board at the beginning of this week. Like, what do we do? What do we want to, do we want to continue these things going? How should we continue? And it's great to see that most of the people that are attending are wanting these to continue at least once a month. That was kind of our plan, was once a month. Also, we're going to probably be branching out to some of our associate members, our aggregate suppliers, our cement suppliers, steel suppliers, and have them do some presentations that are a little bit more tailored towards their area of expertise as well. That was kind of our plan if this went on too long, but that's what we would hopefully be able to do starting in June and going at least once a month, maybe twice. But thank you. That's great to know. I appreciate you guys, your feedback.
I think That's a great response. I'm excited about this. And of course, eventually we'll run out of presentations to give, and in which case we just start over, right? And we host this same presentation again for anyone who might have missed it.
I mean,
So
yeah, or I could just get on once a month for an hour and just like read a chapter of a book or something. Maybe that's what people, I don't know. I should have had that a poll question. If I run out of, would you just want to watch me in my pajamas read a book? I don't know. I think that would be fun. We'll see. Okay. Let's see here. We've got some other poll questions, but I'm going to do those later. So we'll move on here to another one here. Okay. Concrete pipe outer diameters based on 6-inch cleanout wall thickness and pipe angle at cleanout. Okay. So this is where, if we go through that handout that I had there, right? I'm going to start going through the handout, and these are some of the tables that you will find in the handout, okay? So this is where we start talking about skew angle, right? And so if you notice at the top of this table, and if you've downloaded that handout, you can print it out and follow along, or you can just get it later, or you can just put it up on your screen and follow along. But the angle of the pipe entering the box, that's your skew angle across the top. So we've got 0 degrees, 5, 10, 15, 20, 30, and 45 degrees. Once you get beyond 45 degrees, it's really tough to make anything work there. Even at 45 is pretty intense. So keep that in mind. We have seen situations where, unfortunately, because things happen in the field, they tried to cut into like the corner of the box, and we really need to try to avoid those kinds of things. Owners really don't like that. We don't like doing that. So this table and this way of calculating it as we walk through it is hopefully going to be really helpful to you in your design, so that you could figure out, what we need to do to make sure these pipes are fitting in there. Okay. So what we've got is down the left-hand side, you've got your internal diameter. So whenever I'm saying diameter, just keep this in mind. If I say diameter, I mean internal diameter, your inside diameter. If I'm referring to the outside diameter, I will always say your OD or your outside diameter. I don't always say ID or inside diameter when I'm talking about the diameter of pipe. But just know, if I say it's a 24-inch diameter pipe, that's your internal diameter. And then when it's an outside diameter, I will actually say outside diameter. Now keep in mind, these are for your B wall thickness. If you go back and watch our very, very first webinar we did back in March, where we talked about pipe fundamentals, we went through ASTM C76, and that gave you your wall thicknesses for A, B, and C walls. And if you remember, I gave you a little rule of thumb that you take your internal diameter in feet and you add 1 inch to it, and that's your wall thickness. So if we had a 24-inch pipe, that's 2 feet diameter plus 1 inch, that's a 3-inch thickness. So your wall thickness would be 3 plus 3 plus your 24 inches would be 30 inches. So your outside diameter is 30 inches. So that's for B wall only. So this table will only work. And I've got that note in that handout, so you don't have to worry about remembering that. It's written on there. This is for B wall. Both of our manufacturers here in the state, that's what we provide is the B wall. Typically, all of our forms are for B wall. So we can do different ones if we need to, but we don't typically like to. So this is that table, and then we look at these skew angles. So it tells you what your outer diameter is when you start skewing. So notice here, let's take our 24-inch pipe here, and you go 30, and then you skew it at 5 degrees. It makes it be 30.6. At 10 degrees, it's 31.5. At 15, it's 32.7. At 20, it's 34. So you remember where I showed the picture of the 2 core holes? That's where if it skews, then you've got to do, just a singular circular core hole isn't going to be enough. You've got to do 2 at a side. Let's look at this. This is also on that handout here. This is what it looks like when an 18-inch RCP and a clean out outside diameter of 18-inch RCP would be 23 inches. So we look at that and it comes in at that. Now, when we look at a 15-degree skew angle, this is the calculation that actually Randy did all of these. He populated this table based on this calculation here. Your 18-inch RCP coming in at a skew angle of 15 degrees. So you take your outside diameter, and then you times it by 1 over the cosine of 15 degrees plus the tangent of 15 degrees times the wall thickness. which would be your 23 times 1.04 plus 0.26 times 6 inch wall. So you get 25.4 inches is now your new outside diameter. So that's the calculation that was used to populate this table. So there it is. So if we just go to the table, instead of doing that calculation every time you can go to the table, here's our 18 inch. If it's a 0 degree skew, it's 23 inch outside diameter. If it's a 15 degree skew, it's a 25.4 inch outside diameter. So keep that in mind when you're thinking, okay, will this pipe fit if I skew it, if it comes in at a skew angle? Now, I know there are some programs when I was doing design for UDOT drainage projects. I know like MicroStation had the storm and sanitary I was using. That would typically calculate and try to do that. But I always go through and check by hand as well. Just look at this table and just make sure that I sized my box correctly. I don't want to miss anything and get out in the field and realize, I called out a 4x4 and I should have called out a 5x5. So keep that in mind. And that's why we're trying to put that table on the UDOT one too, to help you so that you can see. And that's where we based it all off of, is this table. Okay. This is a typical box sizes. This is also in the handout here. So if you look, you've got your horizontal dimension available for the pipe outside diameter. So for instance, this gives you our box size. So if I look at it and I say, okay, I'm using a 3 foot by 3 foot box, a 3x3, the horizontal dimension available for your outside diameter is 28 inches. Okay, so that's what it would have to be for a 3 foot box, 28 inches. So you've got to make sure your outside diameter is less than 28 inches there. So if we had a 3 foot box, we would need, our 24 inch pipe wouldn't be able to fit in a 3x3 because our outside diameter is 30 inches. So we could do an 18 inch. We don't typically see many 21 inches anymore, but you used to, if you dig up old pipes, sometimes you'll see a 21 or a 27 inch, but you could go a 15 or an 18 inch pipe in a 3 foot box, but you couldn't go much bigger. You couldn't go any bigger than that. So your 24 inch, you'd have to go up to your 4 foot box. So this is the situation that we see sometimes, where you've got your box with your hole that's available there, because you've got to keep a couple of inches on either side of it to make sure that we're okay. And we don't want to see this situation out in the field. This is much better. So make sure that we're checking that out. All right. And so that goes through the first couple of pages of that handout, shows that. This is our manhole. This is our next page, I believe the third page of that handout. Yep, third page here. So this is what it looks like here. This is your manhole and your ring and cover. And we'll go through some of that there. This is a configuration of what it looks like there and how we configure it. Now, couple of things to keep in mind here. All right, this is what we want to look. If you notice down at the bottom there of the page, it says, or this slide, it says manholes and combo boxes with ring and cover. The suggested cover over the top of pipe is 23 inches. Now, I'm going to ask a poll question here. Let's do another poll. And this is, when you're designing storm drain, what is the typical minimum, RCP storm drain, what is the typical minimum cover you're trying to reach? Okay, we'll let you keep going here for a minute. All righty. Okay, perfect. Now, fair warning, I meant to ask this before this slide to see if it changed the results at all, but it looks like some of you beat me to it, where I'm saying the minimum suggested cover is 23 inches. A lot of times we get calls and people say, hey, I've got minimum cover. What are my situations? What are my options here? Now, realistically, and we've talked about this every week, where we talk about, concrete pipe as a structure. We can design this structure to handle any load. But what we need to step back and look at is just, a lot of people will take that as, oh, wow, I could do 6 inches of cover over a pipe. In some situations, sure. That's probably a possibility. But what we don't realize when we're looking at 6 inch cover on a pipe, well, okay, what about the bell hole, the bell that comes up and sticks up? Is that going to stick into our pavement section? What is our asphalt pavement? You don't want your pipe in your asphalt or your concrete pavement section if you can avoid it. What about in your base course? Do you want it sticking up into there? Those are things that we just look at and go, oh, 12 inches of cover, we're good. But then you start thinking, okay, how's this going to tie into the box? How's this going to tie into a manhole or a catch basin? What's going to happen there? How do we do that? How can we tie that in? Is it really going to work? So this one says 23 inches is the recommended depth for this. Okay, so I'm going to, oops, lost my cursor there. So I'm going to go ahead and hide that now, and we're going to go back into this presentation. So 23 inches, we need to, keep that in mind. And this is the typical table here. I pulled this off of that third page there. Assume your RCP for pipe diameters and wall thickness. Okay, so your pipe diameter, again, this is for a B wall, right? This is a B wall thickness. So we've got our 24-inch pipe. We've got 3-inch thick. So this tells us what our hole diameter needs to be to get into that box, and then your minimum difference from ring to pipe invert. Okay, so when I go back to this, let's walk through this so that we're understanding what it is and where these distances come from. Okay, and back on this first page, it shows at the top of that third page of the handout, it'll give you, okay, 6 inches for your ring and cover, and then you've got your lid. All right, and so think about that lid. Okay, we're going to go, all right, our lid is typically going to be maybe 6 to 8 inches, but it varies. It depends on that. So if you've got 6 inches, and then you've got another 6-inch, right? So 6-inch ring and cover, a 6-inch lid, and then you're tying that into a riser, right? We have to make sure we're leaving 5 inches of 5 inches there. So we've got our 6-inch lid, and then our riser, and then our 5 inches. So when you start looking at it, or actually this is for a 12-inch lid, I apologize. So 6-inch ring and cover, and then your 12-inch lid, and then your 5 inches. That's where we get that 23-inch recommendation. So that lid can maybe change and vary where it gets a little bit smaller than 12 inches, but it's a good rule of thumb. We do have some options when we start looking through this. So this table gives you your minimum difference from ring to pipe invert. So this is a good table to have too, where you're looking at it and going, okay, I've got a 24-inch pipe. What is my maximum, or my minimum depth, I should say, to the invert of that 24-inch pipe? And so I look over and I say, okay, it's 50 inches. That would give me that 23-inch cover, so that I've got my 5 inches in the pipe, and then I've got my the core hole, the 2-inch core hole, and so just keep those in mind. That's something that we really need to keep in mind there. Okay.
Hey, Jason.
Yeah, Randy, go ahead.
So all of these are great guidelines, and if you hit this guideline, you don't need to spend a bunch of extra time or call us or do anything else. Doesn't mean that we can't make things work and that we don't make things work a lot of the time. It's just kind of giving you an idea. Try and stay in the guidelines and be conservative where you can. And if you can't, then we need to think about it a little bit more and make sure what's happening.
Absolutely. You're absolutely right there. So these are some alternate configurations. There are some situations and some municipalities that would allow you to put the grate right on top of the box. And if you've got, like, for instance, a 18-inch by 48-inch grate, and instead of having a riser, sometimes you're able to put it right on the box, so you don't have necessarily a lid or a riser. It goes right on the box itself. And so that's a situation. But if you look at the top one, this is your curb back grate. You're adding 6 inches for the TBC on the back of that grate, but your suggested cover over the top of the pipe is, again, 23 inches. So that's for your basically your grate and cover, your lid, and then your 5 inches, and then your core hole depth there as well. So that one, if you do it that way without tying it directly to the lid, it's just that 23 inches. If you do a 4-inch frame and grate, then you can minus 2 inches off of that table. Or there are situations where maybe we'll use a recessed grate. So the suggested cover over the top of the pipe is 17 inches in that case. So that would be that depth minus 6 inches. So now we're shooting for, okay, we want, instead of 12 inches of cover, instead of 24 inches, 24 inches, now we're closer to 17, 18 inches of cover. But there's always situations that we can talk through and help you through. But like Randy says, this is a good guideline, good rule of thumb when we're designing these, and it's a good check to make sure that we have that information there. Okay. So, but feel free to call us if you have any questions. We don't want you to say, oh, we can't use it, it can't work. We're not going to be able to. Let's brainstorm. Let's talk about what we can do. But these are good for just checks, and then we'll walk you through the rest of them there. Okay. This is an example of that recessed grate I was talking about, where we can take that 6 inches off, where the grate is actually, the steel is cast into the box itself, so you have your recessed grate there. This is that example there of that grate where you've got your 6 inches of your back, your curb there, your hood vent there for your curb. Those are some situations there. Obviously, the lid varies depending on the manufacturer there, but this is an example where we core the hole there in the plant. We've got that distance between there. This is an example of a box with some knockouts that maybe you can use. Those are typically not used on UDOT projects, but APWA does allow certain sizes to do knockouts. This is when we're doing that inlet box. This is what that table is. So this is your 4th page on your inlet box. Kind of the same thing where you've got your minimum difference grate to pipe invert. So keep that in mind there. This is that configuration. So it's the same thing. Pages 3 and 4 of that is basically the same thing. One's just your ring and cover for your grate, and then this one's more if you're doing like a curb back inlet. This one is the suggested cover over the top of pipe, and this is 19 inches. So keep that in mind there. That's your depth to invert is shown in the table over here. So notice they're a little bit less than some of those other ones that were in the other one with that ring and grate or ring and cover. Okay. So again, this is a picture of a knockout so that you can look at that. This is typically for smaller boxes. This is used really only in those boxes that don't require structural steel. The wall there is thinner, you can see. So instead of the 6-inch wall, it's thinner so that you can knock it out in the plant and then pour a closure pour around it. That is like I said, pretty typical more for like APWA municipal designs, but you don't see those very often, if at all, in UDOT. Okay, so again, alternate configurations. If you just have your frame and grate or a recessed grate, you can subtract the 2 inches or the 6 inches for your recessed grate there. Okay, more examples of boxes here and what they look like there. Okay, let's get into manholes, though. This is what I really wanted to, so I kind of blew through those other ones.
Hey, Jason.
Yeah, Randy.
I before you go to the manholes, I think there's some cities and other jurisdictions that on a catch basin, if it's like a 18 by 48, or depending on the size, that grate can fit right on the base and doesn't have to have a separate lid with it, which gets you back down to your like 13 inches of cover or something. So
okay, so that's good to know. So keep that in mind. Yeah, if it's that 18 by 48, and you can set the grate right on it, so it's kind of a recessed situation where it goes in, and then you've got your curb in around. Okay, that's good to know. So you'll want to check as a designer. You want to check some of those things and see what you got there. Okay, this is the situation we see every now and then, right? Where you've got 2 pipes coming into a manhole. Very common to have 2 pipes coming in, and then depending on the angle, you want to look and see what that distance is between. So if you look, this area here, this is that critical point, right? We have minimum recommendations. This is page 5 of the handout that we're going to go over here. And so this is what's called your A distance, okay? We're going to call this A. So keep that in mind. This is that important part in between the 2 pipes there. So when you look at it here, this is, as I mentioned, this is your A distance. Okay, so, and then you've got your angles of your pipe coming in. All right, so when you have multiple pipes coming in at different angles and at multiple elevations, this is that page, that sheet 5 of the handout. We've got a formula here. You have your M times your angle equals Y, and Y is the distance between, if you look on that page 5, that's the difference between the angles all the way across that face from the middle of each pipe. That's that distance there. So that would be your M is your circumference divided by 360 degrees. So you just look at the table on the right there that I have. That's where we've got it there. 48-inch manhole, your M would be 0.419. For a 72-inch manhole, your M is 0.628. So that's That's what we've got there. We've got that M value for you already there. So your Y is that arc distance between the center line of the pipes, as I mentioned, and your Y is calculated, or excuse me, your A is figured out by you go Y, which is your arc distance, which is your M times your angle, and then you've got your pipe 1 arc size divided by 2, pipe 2 arc size divided by 2 equals A, and then you get that A distance between the openings. I know that's kind of a lot, so let's walk through an example there. Here's that page again. So before we get doing an example together, we're going to look at the suggested A distances, okay? For 48-inch through 72-inch diameter manholes, the A distance should be 6 inches or greater. So you want to make sure you have at least 6 inches in there in that A distance there. Now, one thing I do want to, well, I'll get to it in a second here. The second one is for 72-inch, for manholes larger than 72 inches, it is recommended to have 8 inches or greater between there, okay? So we want our A distance to be there. Now, keep in mind that A is, if you have a manhole, right, we're thinking about this, your A distance is going to be different on the inside than it is on the outside, right? So this is measured from the inside. So you want to make sure you have 6 inches of material on the inside of that manhole. That's really important to remember. You're looking at it on the outside, and you'll go, oh, yeah, we got plenty of room out there. Well, as the pipes come in, depending on the angle they're coming in, you may have less, much less on the inside, right? So keep that in mind. All right. So let's do an example. We've got 2 pipes. They're 36-inch pipes coming in at an angle of 90 degrees. So pipe number 1 is 36-inch, 90 degrees. It's set at 90 degrees. We go 0 degrees is directly up. So we'll say north, due north is 0 degrees. So you go 90 degrees is when you go to the right there. And then when we go down, the other one is at 180 degrees. So the difference between them would be 90 degrees. Okay, so we need to check that A distance when we're sizing a manhole to make sure that we have the right size. We're going to try a 72-inch diameter manhole. That's going to be our first check. So we're going to say, okay, we're going to try this 6 foot manhole. We're going to see if this works. Okay, so we figure out our Y, and that would be our M value times our angle. So we go over to our table. Oh, excuse me. We go to that one table there that we had, and so for a 72-inch manhole on that table, if you look on that one, 48-inch was 0.419, 60-inch 0.524, 72-inch our M value is 0.628. So it would be 0.628 times the degrees between the difference between the two, which is 90 degrees, and we get a value of 56.52. So write that down, keep that there on the edge there. You're going to hang on to that one there, 56.52. All right. Then we go down to the table that's on that sheet 5 of the handout, and this is for our arc size. We're going to be able to find our arc size per manhole diameter for different pipes. We've already calculated these for you, so it's easy for you. You just go to this table and pull it off. So we said 36-inch pipes. So we go over here and we find, okay, 55.1 is our arc size for a 36-inch pipe. And since we have 2 36-inch pipes, that's all we need is that 55.1, okay? So let's go back to our equation here. A equals Y, which we said was 56.52, minus our first pipe's arc size divided by 2, which is 55.1 divided by 2, minus, again, our second pipe's arc size divided by 2, which is 55.1 divided by 2. So we get 56.52 minus 27.55 minus 27.55, and our A distance is 1.42. Is that acceptable? No, it is not. Oh, I got it wrong. 1.15, sorry, 1.42 it should be. I wrote that in wrong. I apologize. I was getting ahead of myself this morning. Less than the 6 inches. 1.42 is also less than the 6 inches, turns out. So we're going to have to try a larger diameter manhole, okay? So let's look at this. Let's try another one. What if we tried an 84-inch diameter manhole? So we step up that next size. So now we're looking at that 7-foot diameter manhole. We do our M angle where we look at that 84-inch. Our M is 0.733. So we times it by that 90, and we get 65.97. We're going to write that down, 65.97. Okay, perfect. We go over to our table again. Now we go to the 84-inch manhole, and the arc size is 53.4 now, okay? So that's going to be our new arc size for an 84-inch manhole. Okay, our calculation again, Y, 65.97 that we just wrote down, 65.97, yes, minus 53.4, which is our arc size, divided by 2, which is 26.7, minus the arc size for the second pipe, 53.4 divided by 2, 26.7, we get 12.57. 12.57 is more than the 8 inches suggests, because remember, we kicked up to a new size. 84 inch is bigger than 72, so we went from the 6-inch recommendation to the 8-inch. So that's where we go up there. So this manhole size is sufficient. So if we had two 36-inch pipes coming in at a 90-degree angle, we would need an 84-inch manhole. Okay. All right, and so this is what I was talking about there. If you notice there, that distance between the two, that to me looks like a little bit less than 6 inches, but it might be close. I don't know. This is another example there where they come in. So you've just got to look at, and this one would be the two different sizes coming in at a different angle between the two. So consider that. And this is a picture that I've always thought was pretty cool, where they cast another pipe on top. So instead of a manhole, they just have like an access point that's been cast into the top. This is something that we can do. If we can avoid it, we would, but this is an option that we can do as well, just as an access into a pipe. Again, we try to avoid this where we can, but it's not always avoidable. But these are a little bit different. Again, manholes, a lot of these are just the handling steel in them. Just other pictures of core holes there, coring into the pipe and then or into the manhole. This is another one there that we've got that has a good sufficient cover on it. But anyways, just wanted to share those pictures with you. I've got one last poll that I'm going to do and then we're done.
Jason,
Oh, whoops. Yeah, Randy.
before you do questions in the poll, I'd just say sometimes we try to, at least on catch basins, the difference between a 3x3 and a 4x4 is just not that much money. And you sometimes will cause yourself a lot more problems by trying to, engineer it too tight. So if you've got room, if it's not a problem and you're close, you ought to go to the next size up.
Okay. Is that typical for manholes as well?
Manholes can get to be a little more pricey when you get into some of the larger ones, and we can look at different options, maybe a vault or something else. It really just depends on, kind of where you're at.
Yeah. Okay. Good to know. Good to know. Thanks for the info. So yeah, keep that in mind. That's a great point. We will do this last. Well, I'm gonna just go ahead and review the takeaways before we do this last poll, and then we'll take your questions. So if you have questions, go ahead and start typing those in. I see that we've already got a couple, so we'll be answering those and going back. We talked about the changes that we're proposing to the UDOT catch basin drawings and that we're working to get approved. We talked about sizing catch basins, what to remember when you've got skew angles and things coming in, what your minimum size is for your length or your side length of your pipe. Excuse me, man, I am all over the place here. Your minimum side length of the box for different pipes at skew angles. We talked about sizing manholes when two pipes are coming in and different angles. So that's what we talked about today. Before we get to the questions, I'm going to launch this poll. All right, I'm just curious to see if any of you have gone back and watched any of the previous videos. We've had 7 videos posted to YouTube, our YouTube channel, and the answer for the most part is no. And then it looks like kind of what I expected. Wait, these are recorded and posted to a YouTube channel? I had no idea. So I will say this is exactly what I expected, the 3% yes, considering we've only had like 4 views total on all 7 videos, so I kind of figured nobody had. But I wanted to use this as an opportunity to let you know that, yes, we do have these recorded. So if you have questions and you go back and you go, what did they say about that? What was I forgot what he said. Not only am I more than happy to share any of the slides with you, any of the PowerPoint presentations, I'm also happy to walk you through it if you want to call me. This is my contact information that I'll post up here afterwards as we answer questions. But as you can see, most of you know, 1 or 2 maybe have gone back and watched, for reference. And then now I've informed you and done my sacred duty to tell you that these are recorded and on our Mountain States YouTube channel. Just go to YouTube and search for Mountain States Concrete Pipe Association, and our YouTube channel will come up, and you can watch any of the previously recorded sessions. You know, there's been some great ones. If you want to go back for reference and watch and look, go ahead and do that. That would be awesome. Okay, we'll go ahead and take questions now. And I'm going to pull that up here. So feel free to stick around. I know we're a little bit after the hour, but if you want us to go through, we will be, I'll be answering your questions now. All right. Oh gosh, man, I forgot to go over that, Jeff. I'm sorry. Okay, Jeff Erdman it says he's left, so I'll have to send him an email. He asked a great question on that slide where there was some gray shaded area. If you download the handout, there is a note on there that talks about what the gray shaded area represents, and that is for anything that's below that dark line and that was shaded in that first one when we were talking about sizing catch basins and different skew angles. That was just that any size below that line would not fit in a 6-foot wall or a 72-inch sidewall there. So you would have to have a special design and go up. Now that was only when the maximum sidewall was 72 inches. With these new boxes that we're doing, we're going to remedy that, and so this will have to be updated. But the largest size we're going to be doing with these new UDOT catch basins and hopefully get adopted with APWA will be 8 by 8. So we're trying to increase that size. But right now, that would be just basically we need a special design. It would exceed what is currently in the UDOT catch basin, the cast in place catch basin designs now. And so we would have to do a special design for those. But hopefully when these are adopted later in the fall, we'll be able to have that go up to 8 foot, and I'll modify that table. So where you see that shaded area in the handout, that's just those boxes you have to do a special design because it exceeds 6 feet in your sidewall of your catch basin. Okay, great question there. And Ryan, yes, do you provide a certificate for your presentation so we have proof of a PDH? I do indeed. I look through and see who attended, and then I will email those out on either this afternoon or first thing Monday. You can expect those, Ryan. So I'll be sending those out for this presentation, for the PDH for today, and then we can we'll get you from there. Looks like those are all the questions that I'm seeing here. Are there any other questions? Speak now or forever hold your peace. I'm going to give Randy and Heather and Mike a second if they have anything they want to say. Randy, while I'm waiting to see if any other questions come in, anything you'd like to add to the presentation today?
I just want to thank everyone for attending, and if you want some of these presentations done in your office, I think it would be good to get Jason out. I think it's time. So feel free to call him and he'll arrange to come out and see you.
Yeah, I would absolutely love to come out to your offices and give you a presentation. I will warn you, if you typically I wear, business attire, business casual. If you ask nicely, I might consider wearing my pajamas to your office. So just let me know there. So, okay. Any plans to update UDOT's manhole drawing? Right now, it's only for 4 feet. Yes, Jeff, great point, great question. I think that is the discussion that we've been having, that once we get these CBs done, we would look at your CB11 drawing, which is your manhole drawing. You are absolutely correct. Currently, it goes up to a 48-inch, so anything above that is a special. I believe that once we get these done and we figure out the process and we can get it all squared away with the catch basins, that would be our next goal and our next step. We were originally asked and approached by Robert Stewart, who was over the materials at the time, to standardize our catch basin situation, because that was the one that was giving our inspectors and our REs the most issues, and so that was the main focus. But yes, absolutely, I think that could definitely be updated there. So yeah, so great question. We would love to do that. Okay, any other questions? It looks like we're good to go there. Heather, anything you want to add?
No, I think this was a really great presentation and a good introduction to what's to come with the UDOT Catch Basin project. Yep. And I appreciate everyone showing up today and giving us the chance to give you a little bit of knowledge about the industry, and I hope everyone has a really great weekend.
As do I. As do I. And I believe that Blackham had to step off and leave for another meeting, so I don't think Mike's there. So we want to thank Randy and Heather and Mike for taking part today and giving their feedback and their assistance today in answering, helping answer some of those questions. If you do have any more specific questions, please feel free to give me a call. My contact information is on the screen now. Feel free to call me or email me. And if you need to go back, if you had any issues downloading the handout, just email me and I'll email you a copy. It's a PDF, a PDF copy, so I can just email that to you. So have a great weekend, everybody. We'll catch you next week. We've got 2 more of these planned for the next 2 weeks, and we hope to see you all there. Have a good one. Have a good, happy weekend. We'll talk to you later.